This is the key to section 1.5 part 5. In both situations, number 1 and number 2, you're solving quadratic equations. And in number 1, you're going to solve it using the quadratic formula, and in number 2, you're going to solve it using the completing a square. Now remember, what makes these quadratic equations is the fact that it's of this form: ax squared plus bx plus c equal 0. So it has to be that form, so it has that x squared term. And the coefficient of a cannot be 0, because if it was 0, there would not be an x squared term, and then this would be linear. So notice in both cases there's an x squared term, and the coefficient of this leading term, we call it a leading term. The coefficient of this leading term is 1, and the coefficient of this leading term is 7. Now when solving using the quadratic formula, you want to make sure it's in general form, and that's general form right here. So this is in general form. So basically you're going to get all the terms to one side and 0 on the other. So in this case, I'm going to go ahead and subtract 2x from both sides. Now make sure it's in descending order. So I'm using the word descending order. Alright, in descending order, so that way you don't make a mistake with the a, b, and c. Okay, so when I rewrite this and put in descending order, I get 7x squared minus 2x plus 3 equal 0. Alright, now the quadratic formula states that the solutions to this quadratic equation right here, that's in general form, is, and since this is my variable x, I'm going to say x equals the opposite of b plus or minus the square root of b squared minus 4ac divided by 2a. Alright, so that's quadratic formula. So all we're going to do here is just take the values of a, b, and c and substitute them back into this formula. Okay, so it's a good idea to determine what a, b, and c are. So a in this case is 7, b is -2. Make sure you write these correctly, otherwise you'll be substituting wrong values into here. And then c is 3. Alright, so I'm going to get x equal, and remember this, you can read this as the opposite of b. The opposite of b. So if b is -2, the opposite of -2 is a positive 2. Plus or minus the square root of b squared minus 4ac. Now, in a later section, this is going to be called the discriminant. So we're going to talk about the discriminant here. But anyway, for right now, just think of this radicand as just b squared minus 4ac. And we're going to go ahead and put these in parentheses. So in this case, b is -2, and I'm going to square it. Now, if you didn't put it in parentheses, you would probably, if using your calculator, you're going to get a -4, and that cannot be, because remember, you're squaring. This says I'm squaring b. So if b is positive or negative, that's always going to be positive, never negative. Because a negative times a negative is a positive, and a positive times a positive is a positive. And if it's 0, then 0 times 0 is 0. So it's never negative. So always use parentheses here to be on the safe side. Minus 4 times a. A is 7. Notice I'm using parentheses. Times c, and c is 3. Again, I'm using parentheses. All this is being divided by 2 times a, and a is 7. Alright, I'm going to go ahead and simplify this radicand. So I get 2 plus or minus the square root of -2 times itself is 4. A -4 times 7 times 3. Use your calculator if you need to. Let's see, let me get my calculator out. Okay, so when I multiply -4, so I'm saying -4 times 7, so times 7 times 3, I'm going to get -84. So 4 minus 84, all that's being divided by 14. So I get 2 plus or minus the square root of -80 divided by 14. Alright, now let's talk about the square root of -80. Okay, so in this case, notice it does say make sure you simplify radicals if necessary. And so we can go ahead and simplify the square root of -80. I'm going to go off to the side right here and do that. So the square root of a negative 80, remember, is the square root of a negative 1 times the square root of 80. Negative 1 times the square root of 80. And negative 1 is I, so we're going to end up with two imaginary solutions here. And then the square root of 80, a perfect square that goes into 80 is besides the number 1, is 4. But I want you to notice something. If I do 80 divided by 4, I get 20. And then 4 can go into 20 as well. So we have this 4, and then this 4, that's a factor of 20, so we're going to get 16. So you can use 4, but you would have to reduce it further, or simplify it further later on. So just use the largest perfect square. So always use the largest. The largest perfect square is 16. So I'm going to say 16 times 5. Oops, sorry, I meant positive 16. 16 times 5. And so this becomes I, square root of 16, square root of 5, and the square root of 16 is 4. So this becomes 4I square root of 5. So that's going to be the square root of negative 80. So this becomes 2 plus or minus 4I square root of 5 divided by 14. Okay, now make sure, if you look at this, see this 2, this 4, and the 14, I can simplify those terms. See, I can simplify 2, and then this term right here, and then this term. They're both divisible by 2, so let's just go ahead and do that. So if I divide all this by 2, remember I'm dividing by 2, I'm going to go ahead and rewrite this. All right, so I'm going to say 2 into 2 is 1, 2 into 4 is 2, and 2 into 14 is 7. So you can write your answer as 1 plus or minus 2I square root of 5 divided by 7. So that's one way. So you wrote it in a compact form here with that plus or minus because this was an imaginary solution, two imaginary solutions. Now if you want to, you could have written it as two separate solutions. There are multiple ways of writing this. You could have said 1 plus 2I square root of 5 divided by 7, comma, 1 minus 2I square root of 5 divided by 7. You could have written it in a plus bi form if you wanted to. So you could have said 1/7 plus 2I square root of 5 over 7, comma, 1/7 minus 2I square root of 5 over 7. So many ways of writing this solution. Okay, now let's look at number 2. So number 2, you want to solve this using completing the square. Now remember, one of the steps in solving in completing the square is you got to make sure that the leading coefficient is 1. All right, so in this case, notice x squared, the leading coefficient is 1. If it was not 1, you would divide both sides by that coefficient. So before you complete the square in the variable x's, you got to make sure this is a 1. In this case, it is. So then step 2, we're going to isolate the variable terms on one side and the constant term on the other side. So I'm going to bring all the variables one side, the constant term to the other side. So when I do that, I'm going to get x squared minus 16x, leave some space here because you're going to be adding a number to both sides, equal a negative 15. All right, now make sure you write this correctly. It's not positive 15, it's negative 15 because you're subtracting 15 from both sides. Okay, now let's complete the square on the variable x's. So that's the next part. So the next part is where you're going to actually complete the square in the variable. So remember, the whole point of completing the square on the variable is to get, at some point, is to get a binomial squared. Because remember, this is going to end up being a perfect square trinomial. Perfect square trinomial. That's what this will end up being. So you want this to be a perfect square trinomial so you can get in that form. Once into that form, you can use the square root property. So remember, completing the square involves the square root property. Okay? All right, so the first thing you got to do, once you bring the constant term to the other side, is to take the coefficient of the x term, the first degree term, which in this case is a negative 16. We're going to, remember the next step says take half of that. Either divide by 2 or multiply by half. I'm going to divide by 2. Then it says I'm going to square that. I'm going to square it. And when I square it, I get negative 16 over 2, which is a negative 8 squared, which is 64. All right, now this says I add what I just found to both sides. So I'm going to say plus 64, plus 64. Now this is a perfect square trinomial now. So in other words, I'll be able to factor it as two binomials that are the same binomial. So I'm going to get x minus 8. So you're going to factor this, and when you factor it's x minus 8 times x minus 8. That's what this is. So remember, perfect square, just like a perfect number. So a perfect number, like 25, is a number that can be written as a whole number raised to the second power. So 25 is 5 squared. 36 is 6 squared. 49 is 7 squared. So that's what makes a number a perfect square. What makes a trinomial perfect square is the same idea. Something raised to the second power, an expression raised to the second power. All right, now that's going to equal, now 64 minus 15, 64 minus 15 will give us 49. So this is a positive 49. All right, now the next step, remember we have this form where we have an expression squared equal a number. So when you have that expression, the most efficient way of solving this equation is to use the square root property. So that's the last step. All right, so I'm going to go ahead and rewrite this. And so I get the square root. I take the square root of both sides. Don't forget, though, when you take the square root of both sides, you get a plus and a minus. And so the square and the square root undo each other. So you get x minus 8 equal plus or minus the square root of 49 is 7. Now notice in this case, I no longer have a radical in this part of the problem. So 7 and a negative 7 are rational numbers. So I'm going to end up with rational solutions. So remember, when you want rational solutions, we end up with rational solutions. Rational solutions. When you end up with rational solutions, that's where you're going to split them apart, and you can actually tell me what those rational solutions are. So you can say x minus 8 equals 7. X minus 8 equals a negative 7. So notice I went from this quadratic equation to two linear equations. And so I'm going to add 8 to both sides. So x is going to be 15. I'm going to add 8 to both sides here. X is going to be 1. So the solutions to the original problem are 15 and 1. And you can easily check this to make sure you're correct. You just use your calculator. So basically, you're asking yourself, if you go to your calculator, I'm going to go ahead and clear this. Where we see the variable x, you're going to substitute 15. That's one of my solutions. So you're going to say, in parentheses, 15 squared, raised to the second power, just like this, minus 16 times 15, and then plus this 15, and hopefully you're going to get a 0, because that's what you want this to be. So say equal, and notice you get 0. And you can do the same thing with 1 to make sure what you have is correct. All right, so the solutions are 1, 15. 1, 15. All right, so that's going to take care of this key, part 5, section 1.5.